Welcome all. This is lecture number 5 of vector calculus. In this lecture, we will discuss surface integral and example based on this surface integral. So, what is surface integral? If vector f be a vector function and capital S be the given surface, just like this. So, this is vector f and n cap is the unit vector and ds is the small surface here. So surface integral of a vector function vector f over the surface capital S is defined as the integral of the component of vector f along the normal to the surface. So we can say component of vector f along the normal is basically equals to vector f dot n cap. N cap is the unit normal vector. So where n cap is the unit normal vector to an element ds, and n cap can be defined as grad f upon mod of grad f, and ds is equals to dx dy upon n cap dot k cap. Now see here, ds can be dx dy upon n cap dot k cap. It is in the case when it is xy plane. If it is yz plane, then ds will convert into dy dz upon n cap dot I cap. And if it is xz plane, then ds will convert into dx dz upon n cap dot j cap. So surface integral of vector f over surface S is double integral S vector f dot n cap ds, and ds is defined as per the given problem, as per the given surface. If it is xy, then dx dy upon n cap dot k cap. If it is yz, then dy dz upon n cap dot I cap. And if it is xz, then dx dz upon n cap dot j cap. So what is flux? If vector f represents the velocity of a liquid, then its flux is equals to double integral S vector f dot n cap ds. Basically surface integral, the standard form is also known as the flux. And if this double integral S vector f dot n cap ds is equals to 0, that is the flux of a liquid. That is, if flux is equals to 0, then vector is said to be solenoidal vector point function. Vector f is said to be solenoidal vector point function. So example 1, evaluate double integral S yzi plus zxj plus xyk dot vector ds, where capital S is the surface of the sphere x square plus y square plus z square equals to a square in the first octant. So it is clear that we have to find in the first octant. So first octant means only xy plane. So here we can let phi is a scalar function which is equals to x square plus y square plus z square minus a square is equals to 0. So its vector normal to the surface is grad phi as discussed in the previous slide, del phi. So what is the del? I del over del x plus j del over del y plus k del over del z of x square plus y square plus z square minus a square. So it will be, when we differentiate partially this function with respect to x, then only 2x arises, with respect to y then only 2y arises, and with respect to z then only 2z arises. That is, del phi is equals to 2xi plus 2yj plus 2zk. So unit vector n cap is equals to del phi upon mod of del phi, that is the grad phi upon mod of grad phi. So what is grad phi? 2xi plus 2yj plus 2zk upon mod is 2x whole square, that is 4x square plus 4y square plus 4z square from the numerator we can take 2 as a common, and from the denominator we can take 4 as a common. From the square root, this 4 will comes outside here as the 2, and so the 2 is cancelled out. So it will be square root of x square plus y square plus z square, but x square plus y square plus z square is a square. So square root of a square, or we can write it as a, that is unit vector n cap is equals to xi plus yj plus zk upon a. Now let vector f is equals to yzi plus zxj plus xyk. So vector f dot n cap, this is vector f dot, the value of n cap is xi plus yj plus zk upon a. So write here and make the dot product. So the I dot I, j dot j, k dot k is 1 and rest are 0. So yzx, zxy and xyz, so all are same. So it is 3xyz upon a. So this is the value of vector f dot n cap. So now from double integral s vector f dot n cap ds, which is equals to double integral s, now we can write it as vector f dot n cap, and ds can be replaced by dx dy upon mod of n cap dot k cap. Now see, we have to evaluate this in the first octant, and first octant means only the xy plane. So for the xy plane z is equals to 0. So ds, so ds will convert into dx dy upon mod of n cap dot k cap, and the value of n cap is, what is the value of n cap? This xi plus yj plus zk upon a, and dot product with k cap is z upon a. Only z upon a remains. So putting all the values. So integral, and the limits are, when the z is 0, then x square plus y square is equal to a square. So the limit for y is the 0 to root a square minus x square, and for the limit x 0 to a in the first octant. So the value of vector f dot n cap is 3xyz upon a, and dx dy as it is n cap dot k cap as discussed earlier, it will be z upon a only. So this a is cancelled by this a, and this z is cancelled out by the z. So 3xy dx dy remains. So we can take 3 outside the integral. So integral 0 to a, integral 0 to root a square minus x square xy dy dx. So first we integrate it with respect to y. So the x is the constant. So we can take outside, and the integral of y is y square by 2 under the limit 0 to root a square minus x square. So when we put limit a, then y square will convert into a square minus x square, and when we put 0, then the 0. So it will be 3 by 2, take this to outside. So 3 by 2 integral 0 to a x, and it is a square minus x square dx. So when we multiply this x to the inside, then it is a square x minus x cube. So the integral of a square x is a square x square by 2, and the integral of x square is x cube is x raised to power 4 by 4 under the limit 0 to a. So on putting the limits, when we put x equals to a, then it is a raised to power 4 by 2 minus a raised to power 4 by 4, and when we put 0, then the entire function will be 0. So the a raised to power 4 by 2 minus a raised to power 4 by 4. So it will be a raised to power 4 by 4 multiplied by 3 by 2. So it will be 3 a raised to power 4 by 8 is the required solution. Example 2. Show that double integral vector f dot n cap ds is equals to 3 by 2, where vector f is equals to 4xyi minus y square j plus yzk, and S is the surface of the cube bounded by the planes x equals to 0, x equals to 1, y equals to 0, y equals to 1, z equals to 0, and z equals to 1. So here it is not given that we have to find for any of the octants. So we have to find the solution for the entire plane. So first we draw, take it as x-axis, it is y-axis, and it is z-axis. So now draw x equals to 0, y equals to, so now see, this is a cuboid. So let the name is OABC for this surface, D E, let it is F, and the rest last one is G. Now the limits for this A point is 1 0 0, for this C point is 0 1 0, this F point is 0 0 1. For this B point it lies in the XY plane. So the points are 1 1 0. For the E it lies in the YZ plane, so the coordinate of this E are 0 1 1, and similarly G lies in the XZ plane, so the coordinates are 0 1 0. Oh sorry, 1 0 1, and D lies in the all three plane, so the coordinate for D are 1 1 1. So now see, it has six faces. It has six faces. So vector, so double integral as vector f dot n cap ds can be termed as double integral for the phase OABC vector f dot n cap ds plus double integral for the phase DEFG vector f dot n cap ds plus double integral O A G F vector f dot n cap ds plus double integral B C E D vector f dot n cap ds plus double integral for the face A B D G vector f dot n cap ds and plus for the face G O C E F vector f dot n cap ds. So this function is converted into the six different phases. Now see, let it is equation number 1. Now see, for the double integral OABC, this is the xy plane basically. So in this particular plane z is equals to 0. So this n cap will convert into directly minus k cap because this is the downward side. This is in the downward side. So n cap is converted into minus k cap, and so that mod of n cap into k cap will be minus k cap dot k cap. So it is minus 1, and for the mod it is plus 1. And when we multiply or when we make dot product of these two functions, then only minus yz remains. So double integral OABC vector f dot n cap ds will be minus, and in this particular plane limit for x are 0 to 1, limit for y are 0 to 1. So the integral 0 to 1, integral 0 to 1 yz dx dy. So these are the constant limit. So we can integrate it either with respect to y first or with respect to x first. So but see, it contains z, and in this particular plane z is equals to 0. So this entire function will be 0. So this is the value of double integral for the phase OABC vector f dot n cap ds. Now moving on to the next phase, that is double integral DEFG vector f dot n cap ds. So vector f as it is, now n cap will be k cap, because in the previous case n cap is the minus k cap, and in this case it is k cap because it again lies in the xy plane. Now see, this is the mirror of the this base plane. So it is upward direction. So the n cap will be positive. That is the k cap. Dx dy upon mod of k cap dot k cap. And in this particular case, this lie in the xy plane, and the value of z, this includes z also. So the value of z is 1. So we can write it as double integral 0 to 1 yz dx dy. Now put the value of z is which is 1. So integral 0 to 1 y dy dx. So first integrate with respect to y or with respect to x as per your choice. So the integration of y is y square by 2 under the limit 0 to 1. So it will be 1 by 2, and the integral 0 to 1 dx is x, lie in the limits 0 to 1. So on solving it, we get 1 by 2 is the value. So the first value is 0, second is 1 by 2. Now moving on to the third case, that is double integral OAGF vector f dot n cap ds. So vector f is this. Now see, OAGF is a plane, is a xz plane. So in this particular case, y is 0 and n cap will be, now see, it is in the left hand side. So the n cap will be negative. So n cap will be minus j, and dz dx upon mod of minus j cap dot j cap. Now when we multiply or when we make dot product, then it will be minus minus plus y square dz dx. So double integral OAGF y square dz dx, but in this particular plane y is 0. So this entire function will be 0. So this is the third value. Same as double integral BCED vector f dot n cap ds. Now BCED is in the right hand side and it is in the xz plane. So n cap will be j cap. So it will be minus y square dz dx. And in this particular case, y is 1. So it will be minus integral 0 to 1 dz dx, because y is equals to 1. So when we integrate it, it will be the integral of dz is z under the limit 0 to 1. So it is 1, and again on integrating it will be minus 1. So now moving on to the next plane, double integral OCEF vector f dot n cap ds. So OCEF in the YZ plane. OCEF in the YZ plane in the backward area. So for the backward, that is, it comes like left. So the n cap will be minus I cap. So on putting the values, so minus I cap in place of n cap, and this will be minus I cap dot I cap. So it will be 1. So when we make dot product, then it will be minus 4xz. So minus double integral for the OCEF 4xz dy dz. Now see, it is in the yz plane, so the x is equals to 0 here, because it is see the figure. So when x is equals to 0, then this entire function will be 0. When we put x equals to 0, then the integral will be 0. So now it is the fifth value. And now the last one, double integral ABDG vector f dot n cap ds. Now it is the forward position, in the forward position. So the n cap will be I cap, and in this particular case x is equals to 1. So when we multiply or when we make dot product, then it will be double integral ABDG 4xz dy dz. Now putting the value of x equals to 1 and putting the limits. So taking 4 outside the integral. So 4 integral 0 to 1 z dz dy. So now integrate first with respect to z. So it is z square by 2 under the limit 0 to 1. So it is 1 by 2. and the integral of dy is y. So it will be 4 into 1 into 1 by 2 or 2. So now putting all the 6 values in equation number 1, we get double integral as vector f dot n cap ds is equals to 0 plus 1 by 2 plus 0 minus 1 plus 0 plus 2. So on simplifying, this is 3 by 2, which is the required solution of the given problem, because this we have to prove. Hope you understand this entire lecture and this entire phenomena. We will meet in the next lecture with a new phenomena of volume integral. Thank you.